Uh, Thanks everyone for coming today. Um, my name's Jeff Osman. I manage the technical end of SOLIDWORKS Plastics for all of North America and Mexico. And I have a background in plastics and engineering. I worked for some really good companies that you probably have used on a regular basis. Plano Molding, Process Plastics, which was a toy company. We produced the little G.I. Joe guys that came in a box. And then I worked for a company called Furnace Electric that we did motor controls and definite purpose switching. So I have a really broad range of really tight tolerance molding to toys, which basically you want to flash and you just trim off. So that's my background. I've been with SOLIDWORKS for 17 years. About 3 years ago, I took over this position of managing the technical end of plastics. So just to give you a little background, let me go ahead and get started. You know, this is a great image of, you know, in the 60s when you were a kid, you wanted to see into the future and see what was going to happen, you know, ahead of time. And that's kind of what we're trying to do with SOLIDWORKS Plastics. The thing with plastics, there's no difference with plastic design and any other design process. The product lifeline is the same. The difference is the cost. So what we're trying to do is at the earliest stages of design, if we can find something here before we get to mold manufacture. Molds are not cheap. You can go from anywhere from $10,000 to $2 million to build a mold. And if you start cutting steel and things are wrong, that can cost you a lot of money. The average mold rework in North America right now is 3 rounds of mold rework. The average cost of doing a study that I'm going to show you today is about $7,500. So if you can do that study, you could save a little bit of money ahead of time if you're doing it at this point as opposed to doing it at this point. When you get into production and product launch, things get really, really costly. So we're trying to give you tools that you can use to find out the issues that you have ahead of time. So today we're going to talk about 3 things: simple automatic part preparation, intuitive, powerful material database, and comprehensive results. Those are the 3 things that we're going to focus on. So we'll start with the first one. So let's take a look. All right, so this is a part, it's a common part, it's smoke detector. As you can see, I'm going to show you the end result before we start at the beginning, because you want to see what you finish with first, our goal, and then we'll go from there. So if we take a look at this, we can rotate around how things start moving in. I mean, we're going to start seeing, if I slow things down a little bit, we can start looking at where weld lines are going to happen. Right there, when they come back there. I mean, those are issues. Weld lines are something that, you know, they can cause up to 90% degradation in the quality of the product. So, like a drop test, you could fall into a problem with that. And it's just a matter of moving your gate around, or moving multiple gates around, to get a better result. So once we've done that, let's take a look at the setup. So the nice thing about SOLIDWORKS Plastics is we have the ability to do multiple, what we call configurations, within one part file. So we're doing different iterations. It could be, in this case, if you look at this, we're doing ABS, we're doing PC, I have a family mold in here, I'm doing cool and warp. So we're doing it all within the same interface. I'm not having to export multiple files to do this sort of thing. So let's do our setup. As you can see, the SOLIDWORKS interface, if you look up here, SOLIDWORKS Plastics is just another tab built within the Property Manager. So you have your Property Manager configuration. It's right here. There's two types of meshes that we can use. Let me back up. There is three things that we need to create a plastics file or study. We need a mesh, we need a material, and we need a gate location. It can be as simple as that, but it can be more complex too. You can go in and set different types of temperatures. We can do micromolding temperature changes. We can do cooling micro temperature changes. So it's just a matter of, when you're in your earliest stages of your design, I think it's beneficial just to do the basic three. See how things look. Make sure you're looking for a couple things. Will my part fill? Where are my air traps? And is there short shots? And if earliest stages of your design, if you can do that, I think it's beneficial. As you move down the line and you're getting ready to start cutting steel, you can definitely look into you know, different aspects of pressures, temperatures, that sort of thing. Today we're going to just focus on the three basics. So to create a mesh, as you can see, let me start over because I went too quick. Right here, you see there's two mesh styles. If I right click, because with SOLIDWORKS we try to eliminate redundant mouse movements, so you're not having to dig through a menu. So if I just right click on it, I have two options, auto, manual. We're going to go into manual. The nice thing about SOLIDWORKS Plastics, it gives you the ability to, if you don't use it every day, it's kind of it walks you through the process. So you can use it and then go away from it and come back. So in this case, here's the process. So we can come in, we can add a runner cooling system and virtual mold. So you can add a mold, any kind of tool still you want, P20, S7, whatever you guys are using. And we just move forward. And it's going to go through that. All right. So right now it's asking for my cooling channel. The intuitive interface of SOLIDWORKS gives us the ability to go in and look at water lines like this. So I can pick water lines, or I can easily go in and select them. So maybe it's just a control select. And pick the water lines that I want to use. As such. And then it gives you the ability to set the diameter. We're just going to keep it at default today and assign them. And then you see the water lines. Oh, I missed one. Yep. All right. So as you can see, even though I missed one and assigned it, I can easily go back and assign that. So we've set our water lines, and we can go ahead and, as you can see here, move forward. And here it's asking us what type of mold, what size of the mold, which it really doesn't matter, but you can change that in any way, either coordinate or size. So if I wanted to change the size, I can just grab this, start moving things around, and say OK. And we just add that mold. We're going to go back and we can add that at the actual type of material at any point. At this point, if we had runners, or I mean cooling lines that were in a solid already and not just line geometry, we could assign those. We can also do inserts, cooling channels, mold, runner, pretty much anything. So, but as you can see, going through the process, it designated everything already. So at this point, what we're going to do is go in and mesh the model. And you have the ability to adjust the number of elements. We can go as low, and I'm going to show you low, because our mesh tools are actually more powerful than most molding softwares or simulation softwares out there. So I can go as rough as that, or I can say, you know what, give me that, refine it, let's find a nicer mesh. So as you can see, it's very powerful, very quick. Once you do it the first time, it's great. And then I just have to mesh the mold. And that takes 2 seconds. This gives us some feedback on, whether the mesh the quality is good, number of intersections, that sort of thing. We do have the ability within our meshing tools to go in and if there's non-manifold topology, open gaps, that sort of thing. We do have the ability to go in and fix that, and it would be built right within here, but we're good right now. At this point, what we've created is just a surface mesh. So what we have to do now is create the solid mesh. It's just a matter of coming in and saying create mesh. So it's created the solid mesh on the actual part. And I can create it on the mold. And then you'll see a cross section of the mesh. And you can control the mesh size and how everything looks and the quality that you want. But just standard out of the box, you're getting really good quality there. So at this point, we're meshed. We only need two more things. We need a gate location, and we need a material. So let's jump back to our PowerPoint. So with the simple automatic part preparation, improved productivity and efficiency. It's intuitive. It's built within SOLIDWORKS. You're not having to switch interfaces, export parts. You're doing everything right within SOLIDWORKS. So that's I think, a definite benefit for you guys. So next thing we're going to look at is intuitive, powerful material database. So let's take a look. All right, so here's our database. We do it two different ways. We sort by family, so you have your ABSs, your polypropylenes, your styrenes, your PA66s, your nylons down in here. But you also have the ability to go, if, let's say I use BASF all the time. That's who I use. We have those built in. And we're continuously updating those materials, so you can go in and look for them. The other thing you can do is go in and search. So let's say we're looking for a material group in a polycarbonate. My cap lock's on. With a fiber content of 30 to 50%. Oh. So we can go in and look for individual materials that have those type of things that we're looking for. In this case, we're just going to grab a general ABS. The nice thing about it is in any of our materials, we always have a generic. So if we go to like a PA66, where are you at? Right there. A generic material of a nylon. So in any general material, you're going to be very close to what you're looking for. Your PVT numbers and all that are going to be good. Your shrinkage is going to be good. So you're close, but we give you the ability to do that. The other thing we also have is a user-defined database. So we can go in and create materials. So I can come in and edit a material, things like glass transition, PVT numbers, your viscosity. So we give you a lot of different options for setting up your viscosity. Not only do we do thermoplastic, we do thermoset material also. So, as long as you can get the rheology numbers, we can definitely put it in. We do have a spreadsheet, and you have the ability to import that spreadsheet. So if you're working with a new material manufacturer and need to input that material, we have the spreadsheet. You can give them, they'll fill it out and then go from there. So once we've created, select the material, which I'm going to select that. Next thing we need to do is injection location. So what we need to do, we can do one of two things. We can just pick a spot and have a diameter. In this case, it's 40 thousandths, but that's not what we want. We want to have the ability to do like a tab gate, a D-sub gate, something along those lines. We have the ability to go in and say injection location face, and go in. And head face, and we can come in and pick. So if this is like a tab gate, that's our tab gate right there. You also, any geometry you can create within SOLIDWORKS can become a gate. So it's very easy to do. And those are pretty much the three things that we needed to do. Next thing we need to do is run. I've already run these. As you can see, I have multiple configurations. So let's go in and take a look at what the configuration looks like. Hey, Ron, you want to add anything?
Just that there's some folks who have been putting questions in.
Okay.
We'll try to either get those at the end of the webinar, or we will get you answers, because we'll have your emails as part of the registration. So one way or another, we'll get those questions answered, folks. Please feel free to answer those questions.
Okay. Well, I've got a few seconds. I haven't pulled up, let's see, look at a couple of the questions.
While Jeff's doing that, I'm going to put up a quick poll question. So if folks could answer the poll question, which is, are you a current SOLIDWORKS user? And we'll just leave that up there for about a minute.
All right. So before we jump into this, let me just answer a few questions. Are you able to simulate blowing agents? We definitely do air gas assist. As far as blowing agents, I'm not quite sure. We don't do blow molding, but we definitely do gas assist or any sort of assist of a second material. And yeah, we do have shrinkage or fiber direction, shrinkage, absolutely. And we do have insert molding, absolutely. We don't do thermal forming. Okay, so Richard, right now, what I've shown you, and for everyone who was asking what versions of SOLIDWORKS Plastics we're using, at this point, I have used all of the packages because I've used the cooling. So there's 3 packages: Standard, Pro, and Premium. Standard has basically filling. You're going to look how things are going to fill. It's going to answer some simple questions for you. Will my part fill? Where are my air traps? Where are my weld lines? That sort of thing. Are there any short shots? Pro gives you the ability to do insert molding and some other things. Biofringe, it gives you the ability to do multiple cavities. And then we go to Premium, that gives you the ability to do warpage and cool. So I've kind of jumped around a little bit on that, but if you're just looking for fill, that would be Standard. If you're looking for fill and pack, that would be Pro. And then if you're looking for warpage, that would be Premium. So, all right, I'll jump back to those in a little bit. Let's take a look at some of these results from the fill. So first thing out of the box, we jump into this. We can take a look at, I like looking at just the fill, how things are going to look coming out of it. All right, so I see a couple problems early on here. If you watch over in this direction, we're starting to get some weld lines on some very thin parts. So that might want to make you look at different gate locations or different gating options for that. But we're seeing that right up front. Next thing I like to look at is like pressures at the end of fill. See how things look, or if there's any really high pressures, especially if we're like in these areas, which they're not high pressures, but it would be useful to understand that, especially if you have a lot of like thin ribs that are tough to fill. The pressures are getting really high. As your pressures go up, your shear stress definitely goes up, and your in molded residual stresses go up. So it'd be good to find those ahead of time at your earliest stages of design. We can start looking at temperatures, bulk temperatures at end of fill, where the highest points of concentration are, which normally are around your gate location. We can start looking at, I like looking at shear stresses. They're the first indication if anything is going to go awry. So I like looking at those. I don't see anything too bad here. You can definitely, modify your pressures, temperatures to adjust your shear stresses. Start looking at sink marks. This is a smoke detector. It's a consumer item. We're starting to see a little sink mark here. This is something that we want to look into. And the reason is the amount of volume on this other end here. So that's something we definitely want to, focus on early on in the stages of design. I'm going to go back. Sorry. But here, I mean, I can't stress enough, if you can catch a sink mark here before you get to here, it's going to save you so much money. And one round of mold rework will pretty much pay for the software itself. If you have $1 million mold, which I've had companies in the last 2 years made some critical errors where it cost them $500,000, and we were able to catch it on a demo, which they didn't even tell me about, for a major car manufacturer. You can definitely save some money. All right. So let's go through and look at the results. All right. So we're looking at the results. This is just the flow. We can look at things like volume shrinkage, how much things are going to move. This is just after the fill. Let's take a look at the pack. I like looking at the volume shrinkage first and seeing what the difference between the flow. So highest percentage is 9 on the pack. We're, down a little bit. Looks a little bit better. And that's where, when you get into our Pro package, gives you the ability to control the pack time. The pack time is the most costly in your cycle time. So you have fill time, you have pack, and then you have pure cooling. With our Pro package, we give you the ability to control the pure cooling time and the packing time. We can start looking at pressures and shear stresses again. And actually the shear stresses look really good after the pack as opposed to the fill, as you can see. So see how easy it is just to switch back and forth between and look at the differences is great. The other thing we can do is we can start looking at cooling. So let me load this up.
And while Jeff is loading this up, let me pop up another poll question about how you're currently evaluating your plastic or mold designs. So we'll leave this up for, again, about a minute while.
Yep, everything's loading.
Okay.
So the other thing to mention, if you're not a current SOLIDWORKS user, our basic standard SOLIDWORKS has mold tools to create cavity core creation built within SOLIDWORKS. So you're not paying extra to do cavity core creation. And that works hand in hand with SOLIDWORKS Plastics, which is great. So let's take a look at the cooling.
Right.
Are
Sorry,
you
Jeff,
still?
let me just
Yeah. No, go ahead.
close this.
No, go ahead.
We'll do a quick share. And we have about 25% currently have no tools to evaluate. 44% outsource.
Okay.
24 use in-house.
Yeah, and you know what? A good question for some of you people that are doing the outsource. How much are you spending? I mean, how many molds are you building a year, and how much does it cost you? National average, and I'm working off of a major guy based in Chicago, or a major company based in Chicago. He charges roughly anywhere from $500 to $7,500 per study, and that's not Insight. That's just doing what I'm showing you today. So that's actually more expensive than our software. If you could do that in-house, and if, let's say you did 10 molds a year, if you could save that much money, it would definitely help you out. It pays for the software. So, good insight, Ron. Thanks. So, with the cooling, we can start looking at different things. Part cooling time, how much time it takes to get to its glass transition temperature. We can actually slice it and start looking at things. We can start doing XY plot with our measure command and find out the part cooling time, how long it takes to get to the glass transition temperature. So these are tools that are just easy to use and intuitive that you can get to. I like looking at heat flux because that's going to tell me if I need to improve the cooling at all. But the big thing is I like looking at the warpage. And what I like doing with warpage is, so basically with warpage, I like investigating how things are going to be flat or straight or fall into place. We give the ability to isolate those in any direction. So in this case, this thing is a smoke detector. It basically has to sit flat along this whole edge. So looking at what the direction is, which is right here, I can isolate it in the Y then come in and use that measure command like I said. And let's just pick a couple things along this face. I don't want that one. So just picking a few, how much difference we have, the displacement. So we might want to, take a look at holding it in the mold a little bit longer, that sort of thing. But we give you the tools to investigate and look into that. We can also, so we do two things. So we do in-molded residual, which is warp is a direct result of that, and then we do quenching thermal. So quenching thermal is basically when it gets shot out of a mold at 450 degrees and it's 70 degrees in the press room, what's going to happen? We can definitely also look at that. We can start looking at sink mark profiles after everything's done to make sure everything looks good. And we can look at, first in mold principal residual stresses. So there's plenty of tools there to help you out. On top of that, we give you the ability to go in and look at the reports. We generate reports, so we can go in and look at that. Let me move things around so I can, still can't. All right. All right. So we give you a report that does a summary, gives you some basic information, volume, weight, that sort of thing. Type of material, melt temperatures, mold temperatures, ejection glass transition temperatures, cycle time. So we can go in and do fill time, look at injection pressures, melt temperatures, clamping force, all the information for cooling. And then you can this is very customizable, so if you're presenting it to a customer, you can give all the material information if needed. We're here, we're the pack and between fill and pack, what happens. And then you have the ability to go in and show information like this, which is very presentable to a customer. So Ron, do you have any more questions you want to ask? Looks like Ron just opened another poll. So we'll take a look. It's pretty much what I was going to show you guys today. Let me go to the questions and see if I can answer some of the questions while we're still online before we leave. David, no. We don't give you insight into where to place the cooling lines, but that can be sketch geometry within SOLIDWORks. It's very easy to move around and adjust. It's very, very easy. Tim, you kind of have to know a little bit of what you're looking for and some of the problems. We don't point out that, hey, this is going to be, this one area is going to be a problem. Now, we do tell you if there's a short shot or it won't fill. So we will tell you that, but we won't be able to, the software just doesn't tell you, you know, where the potential problems are. Phil, yes. SOLIDWORks standard does simulate flow and filling without the packing stage. Joe, no, the material database is separate from the normal feature tree. Just because the amount of information on the plastics ends that is needed, we just haven't. It's so complex, but we do update it quite often. It is tied back to and integrated into the file. There's Aldo, no, we don't do blow molding at all. I apologize. Ken, yes, we do multiple gates. There's no limit. I did a 96 gate drop recently for a customer, and it worked great. Accuracy on mesh is, you can set that. You have full control over mesh accuracy. So I was just working off defaults, but you can control that completely. No, Ed's left, but his question is actually very relevant. Why would a designer outside of a mold maker want to use this software? To catch problems at the earliest stages of design, and that's really the key. We have people using our software that don't even touch a mold maker, but are figuring out if the materials if it's filling, everything's correct. So at every stage of your design, the software is definitely useful. Yes, Tim, we can do definitely in molded residual stresses. Not only can we do that, but we can export that. If you use SOLIDWORKS Simulation Premium, you can export the in molded residual stresses directly into SOLIDWORKS Sim Premium, and you can look at it. So what that means for anyone is, let's say we're creating this smoke alarm. We want to do a drop test. Someone's standing on a ladder trying to put it in. It drops. We can figure out how it's going to look after it drops. If it breaks, if because of the molded stresses that we've put into the product, we can tell if it's going to break. Phil, no, actually our premium package is the highest package. Standard is our basic. So standard just gives you fill. If we go to the next level, Pro, gives us fill and pack. Premium is gives us fill, pack, warp, and cool. So Ron, I think I kind of touched on all the questions. Did you want to throw anything else in?
No, we've done our polls. I just want to thank Jeff for taking his time and doing the webinar for us today. I will just say also that we will make a recording available. We'll get a link in a day or so. So you can review this again or share it with your coworkers or whomever. So that will be, again, made available via email. And then Jeff, unless you have anything else, then I just want to thank everyone for their time today. Appreciate your interest in SOLIDWORKS and SOLIDWORKS Plastics, and hope to see you again at a future webinar. Thank you, everybody.